Continuing where we left off, um, the enthalpy change of the reaction of magnesium with hydrochloric acid. So a lot of heat is generated, and that heat, as I said, is going to be transferred both to the walls of the calorimeter as well as the water present inside the calorimeter. So that heat of the reaction itself is calculated in the second set of experiments, and that is expressed in the units of joules. Joules is the unit for energy, especially heat energy, per mole of magnesium. And now, what does the word mole mean? All right, if I had just one atom of magnesium, it would be hard to weigh or visualize, all right? So mole is kind of a bigger quantity. For example, if I say I have a dozen of something, dozen eggs, that means I have 12 eggs. If I say I have a mole of magnesium, the number associated with the mole is 6.02 times 10 power 23. So it's a big, big number. All right. Now this is visible, all right, because one mole of magnesium, one atom of magnesium would be invisible, but 1 mole of magnesium is quite visible because it weighs about 24 grams. So in this reaction, the way you interpret this reaction is that if you have 1 mole of magnesium, all right, imagine that the number here is a 1. Ones are usually not written in a balanced reaction. So you have 1 mole of magnesium and 2 moles of the hydrochloric acid, all right? And in reaction, it generates 1 mole of the hydrogen gas, all right? So you're going to calculate the amount, and also a lot of heat, all right? So heat also can be looked on as a product because it's exothermic, it's coming out. So the amount of heat generated for 1 mole of magnesium is going to be calculated in the second set of the experiments. So in the first experiment, it's trying to find that Ccal, or the calorimeter constant. Okay, so you're going to take a flask, place it on your workbench. You're also going to, from the instruments tab, you're going to find a constant temperature bath. Bring it onto the workbench and set its temperature to 60 degrees centigrade. Okay. So fill this flask with 50 mils of water using the water bottle from the materials tab, and then attach a thermometer to it. Okay. And then what you're going to do is take this flask and 50 mils of water and place it in this water bath, all right? And wait till the temperature of the flask, of the water inside the flask, reaches 60 degrees centigrade. And then meanwhile, you're going to take a calorimeter, and to it you're going to add some room temperature water, 50 mils, and attach a thermometer to it, and then record the temperature. So the temperature should be around about 21 or 22 degrees centigrade, which is the normal room temperature. Okay. Now what you're going to do is take that warm water, the 50 mils of warm water, slightly warm water, 60 degrees centigrade water from the flask, and then use the pour all option and now pour it into the calorimeter. So now the calorimeter contains a total of 100 mil of, initially it was room temperature, but now that you poured in the slightly warmed up water, the temperature of this 100 mil of this mixed water should go up from the 21 or 22 degrees, maybe to some middle temperature like 40 degrees or so, all right? So now record that temperature of those combined waters, okay? So you started out with 50 mils of cold or room temperature water rather. say this was at 22 degrees centigrade. And then you warmed up some water in a flask, and now you're going to take this water and add it to the room temperature water in the calorimeter. So now, after mixing, you will have a total of 100 mils of water, and you will now note the temperature after the mixing of the two waters. All right. So if that initial room temperature water was 21, the final temperature here after the mixing might go up to, say, like 40 degrees centigrade. Okay. So the recording for the first experiment is initial temperature of the cold, or rather room temperature water, 21.5 degrees centigrade. Okay. Maximum temperature of calorimeter after the mixing of the two waters, cold plus warm, that final temperature is 40.3 degrees centigrade. So then the delta T is that T max, or the T final, minus the T initial. So that 40.3 minus that 21.5, and so 18.8 degrees centigrade. So delta T is 18.8 degrees centigrade. Okay. So the Q initial of the calorimeter, when you try to calculate it, it is going to be the mass of that warm water, all right, temperature 60 degrees, the specific heat of water. As I said, it's intrinsic, so it never changes. The second mass is the mass of the room temperature water rather than the cold water. The specific heat of water, which is again the same, 4.184, and then the temperature of the room temperature water, which is 21.5 degrees centigrade. All right, okay. The masses in both cases 50, because there's 50 mils that you took of the warm water, 50 mils that you took of the room temperature water. All right. So 50 mils of water should weigh 50 grams, because remember the density of water is a gram per mil. The specific heat of water is 4.184 joules per gram degree centigrade. So warm water temperature was 60. The temperature of the cold, or room temperature, was about 21.5. And this is a typo. It should have been 21.5. Okay. So you will plug in all those numbers, 50 grams times the 4.184 times 60. Again, 50 grams times 4.184 times 21.5. So this is a typo here. It should be 21.5. So, and then the number comes out in terms of joules. All right. So you have grams here. It's joules per gram degree centigrade. So the degree centigrade and grams cancel. And so you'll get this number in terms of joules, and this number as well in terms of joules. So 17,034 joules is the initial heat of the calorimeter. So the final heat of the calorimeter is going to be the total masses, since you mixed both of those water. So 50 plus 50, that would be 100, times again the specific heat, which is 4.184, and then that final temperature, which was 40.3. So 50 plus 50, that's 100 grams. The CP is 4.184, and the final temperature after the mixing was 40.3. All right, so 100 times 4.184 times 40.3, and so the Q final is 16,845. So heat energy of the calorimeter, all right, the Q final minus the Q initial, all right. Or rather it's the opposite. it should be Q initial minus Q final rather. So 1734 minus the 16845 and you get 189 joules. Okay, so the calorimeter constant per degrees centigrade is the heat energy of the calorimeter, which is the 189 joules, divided by the change in temperature. Okay, so that's the change in temperature. It went from 21.5 to 40.3, so that change in temperature is 18.8. So 189, the calorimeter constant per degree centigrade. So 189 joules divided by 18.8, and it should come out to be 10 joules per degree centigrade. So the calorimeter constant in experiment 1 is 10 joules per degree centigrade. Okay, remember the way you got the 18.8 was 40.3 minus the 21.5. Okay, now experiment 2 requires that you do that experiment with the magnesium and hydrochloric acid 3 times and then you average your results. All right, every experiment is always done 3 times in order to get reproducibility. All right, so the basic procedure is you're going to take a calorimeter, place it on a balance and record the mass of that empty calorimeter, and then remove it to the workbench and attach a thermometer to it. Record the temperature. So basically you're recording the temperature of air because there's nothing right now inside the calorimeter. So that's your initial temperature. And then you're going to add 50 mils of the 1 molar hydrochloric acid. Now this is a solution, that means there is basically it's a combination of HCl and water. And then to this solution of 50 mils of 1 molar, a molar is the strength, all right? So the 50 mils of the acid, you're adding 0.15 grams of the magnesium metal. So they're going to immediately start reacting. A lot of bubbles of the hydrogen is going to be released. So you have to wait for that reaction to be over and then record the final temperature, right? Also then record the mass of the calorimeter and its contents after the reaction. All right, so the first mass was the mass of the empty calorimeter. The second mass is the mass of the calorimeter and this reaction contents. All right, and then of course the final temperature, because the temperature will go up. Initially it would have been room temperature like before, 21.5, and then it would have risen after the reaction is over. So the summary of the trials: the mass of the empty calorimeter is going to be exactly the same for all 3 trials because the calorimeter that you're using is very similar, and therefore they all should, if it's empty, it should weigh the same for all 3 experiments. The initial temperature is again the same because it's a room temperature, so it will be around 21.5 for all the 3 experiments. In the first trial, you use 0.15 grams of magnesium, 50 mils of the hydrochloric acid. In the second trial, the volume of acid solution didn't change, but now you upped it by 0.1 grams. So you went to 0.25 grams of the magnesium. In the third trial, you went to 0.35, another increment of 0.1, so 0.35 grams of magnesium, but the volumes of the acid solution is the same for all 3 trials. Okay. All right, we'll stop this video here and continue this again in a third video. This is a bit of a longish lab.